Okay, so this example is asking us to find the equations of the two lines which are parallel to 3x minus 4y minus 1 equals 0 and 3 units from it. Okay, so there's something I want to point out to you before we tackle this question, and that is an interesting note here is that if you have the equation of a line, let's say it's ax plus by plus c equals 0, then the equation of any line parallel would also have to start out ax plus by, and then it could add on any other number, but the ax and the by has to be the very same. And the reason it has to be the very same, of course, is when you're rearranging your equation in order to be able to pull out the slope, you're always trying to get it back in the form y equals mx plus c, so you can pull out the m, which of course is the slope. The relationship between the coefficient of the y and the coefficient of the x is key. This number here doesn't really play a part in it, okay? But when you rearrange the equation of the line in this form, you're able to apply the slope. But that means that the number before the x and the number before the y, if the slopes have to work out to be equal, which they do if they're parallel, then the coefficients of the ax and the by have to be set out the very same. So when you rearrange this and pull out the m, you would get the very same thing as if you rearrange this and pull out the m. Okay, so that's really useful to note that you've kind of already got the setup of the majority of the equation. The minute you know it's parallel, you know the start of the equation of the line. Now, also, if you have the equation of the line, let's go back to this again, ax plus by plus c equals 0, but you know you want a line perpendicular, then the relationship, of course, between perpendicular slopes is, if you want to find a perpendicular slope, you need to flip and change the sign. So that means that you would flip the coefficients of the a and the y, and again you can add on anything, and also we need to change a sign here. So let me remove that plus and put in a minus. So by flipping these around and changing the sign, when you arrange this equation and pull out the slope for m, and when you arrange this equation and pull out the slope, in other words, the m, the coefficient of the x, these two would multiply together and equal -1. In other words, they would be perpendicular. So if you know that you want a line that is perpendicular to another line, all you need to do is flip around the coefficients of the x and y and change the sign. So, quick example. Let's say you have 3x plus 5y plus 10 equals 0. Well, the equation of a line parallel to that, okay, would be 3x plus 5y. Remember, we've got to keep the coefficients of the x and y the same, plus, and now you can put whatever number you want in there because that's not important. There's plenty of lines, of course, that would be parallel to this line, but it's the 3x and the 5y that needs to stay the same. Anything you want in here, let's put in the number 2 equals 0. That line must be parallel to that line. Now, if I wanted a line perpendicular to that line, I would flip around the coefficients and change the sign. And again, I could add on whatever I want to add on here. We can pick, let's pick 7 this time. That line has to be perpendicular to that line because I flipped around the coefficients and I've changed the sign. So now, you see, if you take the equation of this line and if we decide we want to rearrange it to pull out the slope, we'd get y equals -3/5 x minus 10 over 5, which of course is -2, but it's the coefficient of x that I'm interested in, -3/5. And if I rearrange this one to get, of course, it in the form y equals mx plus c, so I can pull out the slope, I divide across by -3. and I get y equals 5 over 3x plus 7 over 3. That doesn't matter, of course. It's the coefficient of x that I'm interested in, and the slope is 5 over 3. And of course, these are perpendicular to each other, because if you take this and you flip it and change the sign, you get this one. And another way to know is that when you take the two slopes and multiply them, we get, of course, -1. So once you know that you want the equation of the line, or you want the setup of the equation of the line perpendicular, flip around the coefficients and change the sign. And if you know you want the equation of the line parallel, keep the coefficients of ax and by, or the x and the y, should I say, the same, and you've got the setup of the equation of a parallel line. Okay, so back to our example. Our example is asking us to find the equations of the two lines which are parallel to 3x minus 4y minus 1 equals 0 and 3 units from it. So in other words, say this is the line 3x minus 4y minus 1 equals 0. We want the equations of the two lines. I'll just put them in a different color. So say a line here, imagine it's straight, okay, and here, where both of them are 3 units from it, okay? A distance of 3 units from that middle line. Okay, well, there is one thing we do know. Given that these green lines have to be parallel to the black line, we know that they must be of the form 3x minus 4y add something equals 0. And the same with this one, 3x minus 4y add something equals 0. So we know the setup of both these lines. We just don't know this value that goes in here. So we're going to call it C, okay? And we must be able to get two values for C. Now the other issue is, of course, if we want to use our formula, the distance equals ax1 plus by1 plus c in modulus signs, of course, all over the square root of a squared plus b squared. I need the distance between a point and a line. So if I had a point on this line, it would be really useful because I'd be able to use this formula then, given that I know the result, and I know the majority of the setup of these two parallel lines, then I would be able to fill in the distance of 3 and work out the values for C. So the first thing I'm going to do is find a point on the line that I'm given, 3x minus 4y minus 1 equals 0. Okay, so when I do that, again, any two values of x and y that you can sub in that will make the left-hand side equate to the right-hand side will work, or find where it cuts the x or y axis. So this time I'm going to see where it cuts the y-axis. So if it's cutting the y-axis, it is when x is equal to 0. So if x is 0, I would get minus 4y minus 1 equals 0. In other words, minus 4y is equal to 1, because 3 times 0 is 0, of course. Divide both sides by minus 4, and I get y is equal to minus a quarter. So my point is 0 for the x and minus a quarter for the y. Okay, so there's a point on that line. So now I can use that point, that is my x1, y1, and the equation of the lines I'm looking for all start off the same way, 3x minus 4y, but I don't know this value c. I should be able to get two values of c now, so that I get the two options of the two lines that are 3 units distance from that line there. So D is equal to 3. Okay, let's fill that information into our formula. Pause the video if you feel confident from here on. Otherwise, watch closely. Okay, so the distance is 3. A, of course, is 3, B is minus 4, and C we leave as C. So we have A times x1, which is 0, plus B times y1, which is minus a quarter, plus C, have to leave C as C because we don't know what it is, over the square root of, and of course, 3 squared plus and minus 4 squared in brackets. So that gives me 3 equals 3 times 0 is 0. And a minus 4 times a minus a quarter is equal to 1. over the square root of 9 plus 16. And of course, evaluating further then, I have 3 is equal to the modulus of 1 plus c over the square root of 25. And the square root of 25 is, of course, 5. So from here, again, if you have a fraction, you're going to want to get rid of it. And we'll get rid of it by multiplying both sides by 5. That gives you 5 times 3 is 15 is equal to the modulus of 1 plus c. So remember then, as before, what is in the bracket, or in the modulus, should I say, here, the modulus of what would equal 15? Well, obviously the modulus of 15 will equal 15, or the modulus of minus 15 will equal 15. Okay, so the two possible results of 1 plus c is it could equal positive 15 or minus 15. So take away 1 from both sides here and we can solve for c and we get 14. Take away 1 from both sides here and we can solve for c and we get minus 16. And they are the two possible values for c. So now, go back to the question. Our question asked for the two equations. So now we had the equation, of course. We know it's in the form 3x minus 4y plus something. So it's either plus 14 equals 0 or 3x minus 4y minus 16 equals 0. And that is therefore my answer. Okay, so I just want to go back to that example again one last time, because let's say in this question that we dealt with before, where it asked us to find the equations of the two lines parallel to this line, 3 units from it, let's say they didn't ask for them to be parallel, but instead they asked for the two lines that are perpendicular. Okay? So what we would do in that case is, just like before, you'd need to find the point on this line. Okay, which we did do, and we knew we got 0 minus 1/4. Okay, so there's our point. But the setup of any line perpendicular to this one would then be, remember, we swap around the coefficients, 4x and 3y, and we need to change the sign. So if it's already minus, we need to change it to plus. And whatever value goes here, of course, we're not sure of that yet, but that would be the setup of any line perpendicular to that line. So what we would use now for the formula is the distance of 3, but A is 4, B is positive 3, C is C, and of course x1, y1, the point on that line, but this is the setup of any equation perpendicular to that line. So now you've got all the pieces of information you need to find the two equations that are perpendicular to that line.